Hello, my name is Jim Olson, and this is a video where I'm going to explain a general strategy for solving fill-in numbers puzzles. I'm making this video especially for my Math Olympiad students at Macomb Middle School, but I think the video may be of interest to a broad audience. So I have some example problems. If you're viewing this slideshow, you can click the link. If you aren't viewing it, you can use the QR code or you can go here. So this is a Google Doc, and it's going to show the three examples that I'll be doing today on the video. There's the first example, there's the second example, and there's the third example. So the outline for this video, first of all, I'm going to give you a little bit of background knowledge, but I won't go into a lot of detail on that. Secondly, I'll make some comments and preview the strategy. Then I'll state the strategy. Then we'll do three examples. I'm going to move kind of quickly, as is typically what I do in the videos, so feel free to pause and rewind as you wish. First of all, what is an arithmetic series and how can we find the sum? An arithmetic series is a sum which starts with a number, and there's a common difference between each pair of consecutive terms. If you're in a college number theory class or in Math Olympiad in middle school, you probably have seen examples of this. Here are three examples. This one starts with 1 and has a common difference of 1. This one starts with 10 and has a common difference of 2. This one starts with 40 and has a common difference of -3. These are arithmetic series. How do you find the sum? One shortcut is to take the first term, add the last term, take the number of numbers, and divide by 2. I won't be going into detail as to why this works. I think that can be seen in other YouTube videos. For example, the sum of 1 through 7, the first number is 1 plus 7 is 8 times the number of numbers, which is 7, and divided by 2, we get 28. The second example, first plus last is 30. There happen to be 6 numbers here, and divide by 2, and we get 90. The third example, first plus last is 53. There are 10 numbers. Sometimes you need to have a strategy for figuring out how many numbers there are. That could be covered in a different video. And we get 265. So we need to be able to find the sum of an arithmetic series. Here's the first example that I'm going to be doing. Fill in the whole numbers 1 through 7 in the circles so that the sum of the 3 circles in a line is 12. I have a line here. These 3 will add to 12. These 3 will add to 12. And these 3 will add to 12. That's what we mean by a fill-in numbers problem. And these types of problems are very numerous and vary greatly. And so this strategy has a lot of applications. First of all, some comments. Determine the number of sums. On our example, there are 3 sums. Secondly, there are certain positions that get used multiple times. These are what I will call the key positions. In this one, this center location is what I'm calling the key position because it's going to be used in this sum, and this sum. This number right here in the middle is going to be used 3 times, where all the other numbers are only going to be used once. It is the key position, and it's the key to this strategy. Determine the sum of the numbers you are to use. First of all, start with 1 copy of each number, and then we're going to be using the duplicates of the key position. Why do we want a general strategy? it's going to significantly reduce the amount of guess and check or trial and error. Just to do these with guess and check can be very frustrating. We're going to determine the numbers in the key positions, and we're going to know that they probably would work. And its strategy is also going to help us to determine if there are alternative solutions. And it's important in mathematics to not just find the solution, but find all the solutions. So what will the general strategy give us? It's going to give us, first of all, what numbers will work in the key positions. There might be only one key position. The sum of each row or line. Now, the sum may or may not be given. In our first example, the sum is going to be given. It's 12, but sometimes they don't even tell you that. Once we know what numbers are in the key positions and the sum for each row, the rest of the numbers are often fairly easy to determine by guess and check. So what is the general strategy? Determine the total of all the numbers that will be put in. When doing this, do include the extra times the numbers in the key positions will be used. And I'm going to be showing an example of this. This total must be divisible by the number of sums or the number of rows. If not, change your key position numbers because it won't work. The total found in A divided by the number of rows or sums is the sum for each row. These steps go hand in hand. So let's take a look at some examples. So I'm going to switch over to my camera and get out a pencil so that we can solve this together. Okay, here's our first example. Fill in the whole numbers 1 through 7 so that each sum of the 3 circles in a line is 12. Okay, so the first thing we're going to be doing is adding up the numbers 1 through 7. Now this number is going to be used 3 times, but I'm going to sum up the numbers 1 through 7 first. This is going to be first plus last, which is 1 plus 7, times the number of numbers, which is 7, divided by 2. That's 7 times 8 divided by 2, which is 7 times 4, which is 28. Now, the total in each line is 12, and I have 12 here, 12 here, and 12 here. So I have 12 times 3, that's 36. But you'll notice that my sum of 1 through 7 is only 28. The sum needs to be 36. And the difference is going to be accounted for by this center key position that's going to be used 3 times. So 36 is equal to the total, including extras. So I need 8 more. So this key spot has to be 4. This key position has to be 4. And so we do now have a total of 36, and 36 divided by 3 is 12. So that finishing this out is going to be pretty easy. I need to have 8 here, 8 here, and 8 here, and you can kind of see the symmetry. Here's 1 and 7, 2 and 6, and 3 and 5. And I know that that is the only solution. Now let's take a look at an extension. Fill in the numbers 1 through 7 in the circles, but we don't know the sum in each line. It might be, who knows? So we start out the same way. The sum of 1 through 7 is still 28, but 28 is not divisible by 3. So I'm going to be needing to add something to 28 to get something that is a multiple of 3. Well, let's see what the next multiple of 3 after 28 is. The next multiple of 3 after 28 would be 30. So I could add a 2 here. What else could I add here to add on to 28 to get a multiple of 3? You might pause the video and see what you can find. So this is going to be 2 times 1, and the key position will be 1. I could also put 8 here. 28 and 8 is 36. That's going to be 2 times 4, which is going to put the key position as 4. In fact, that's going to be what we had up here. But I could also have 14. 28 and 14 is 42. That's a multiple of 3. That's 2 times 7. So the key position will be 7. Furthermore, using these, we know what the sum of the line is. So 28 and 2 is 30, divided by 3 is 10, and this is going to be the sum of a line. Similarly, if I add 8 on here, 28 and 8 is 36, divided by 3 is 12, and that's what we did up here. If I put 14 in here, 28 plus 14 is 42. 42 divided by 3 is 14, and the sum of the line is going to be 14. Now let's see if you can fill in the numbers. So you might pause the video and see if you can fill in the numbers to get the other 2 solutions. And here are the other 2 solutions. Putting 1 in the center in the key position, the sum of each line is 10. Putting 7 in the key position means it's going to be used 3 times, and each line is 14. Here's our second example. We are going to be using the numbers 1 through 7 again, but this time we just have 2 lines. So that the sums of the 2 lines of 4 squares are equal. We are not given the sum. So we start by adding up the numbers that are given, which is again 28, like the last one. And we have 2 lines. So the sum needs to be divisible by 2, and this is even. And this is even, that's a good thing. So what's going to need to happen is this is the key position right here, because it's used twice. I'm going to need to put an even number here. An even plus an even will be an even, and that will be divisible by 2. And of the numbers 1 through 7, there's only 3 even numbers. I could use 2, I could use 4, I could use 6 in the key position. So let's see what's going to happen when we use 2 in the key position. The sum now is 28 plus 2, which is 30. And then each line will be 30 divided by 2 because I have 2 lines this time, which is 15 in each line. In a similar manner, here we have 28 plus the 4 that gets used a second time, which is 32. 32 divided by 2 is 16. And now fill this one in yourself. If I use 6 in the key position, each line will be 17. So let's go ahead and fill in the answers for this first one. I'm going to put 2 in this position. I know the sum of each line is 15, which means I need 13 here and I need 13 here. You might pause the video and try to do that. So there's going to be some logic here. One of the ways to do the logic is there has to be a 1 somewhere, either here or here. And by symmetry, it's the same. So if I put a 1 here, that's 3. 15 minus 3 is 12. And how can I get 12? Well, the good news is there's only one way to get 12 of the remaining numbers. That's with 5 and 7. So putting 2 here, there's only going to be one solution. And then we need 3, 4, and 6 here. Pause the video now to see if you can get the 4 to work down in the corner and the 6 to work down in the corner. If we put 4 in the corner position, the key position, each line is going to be 16. I believe these are the numbers that work. And if we put 6 in the key position, the sum of each line is 17, and I believe these are the numbers that work. Let's move now to our final example. Here's the third example. Fill in the whole numbers 1 through 9 in the circles so that the sum on each side of the triangle is equal. So we do not know the sum on each side, and the strategy is going to give that to us. The first thing we need to do is sum up the numbers 1 through 9 using our strategy. First plus last would be 10 times number of numbers, which is 9, divided by 2. 5 times 9 is 45. So using each of the numbers one time, I would get 45. But this time I have 3 key positions. This is going to be used twice, this will be used twice, and this will be used twice. The good news is this is divisible by 3, which is good because I have 3 lines here. The 3 numbers that I'm going to be putting in the key positions have to be divisible by 3. So the sum of these 3 needs to be divisible by 3. A number divisible by 3 plus a number divisible by 3 will be divisible by 3. Well, a simple case would be 1, 2, and 3. 1, 2, and 3 is 6. So the sum is now 45 and 6, which is 51. 51 divided by 3 is 17. So this looks like it should work. Let's try it. We're going to put 1, 2, and 3 in the key positions. And I do know that the sum of each line is 17. This is each line is going to be 17. So down here, I already have 1 and 2, which is 3. 17 minus 3 is 14. Now, interestingly enough, there's 2 ways to get 14. I'm going to start with 5 and 9. Over here, 1 and 3 is 4. 17 minus 4 is 13. So this could be 6 and 7. And over here, 3 and 2 is 5. 17 minus 5 is 12. So I have 4 and 8, and I already have a solution. But since I had a choice here, let's see if we can solve it. Instead of using 14 with 5 and 9 here, let's try 6 and 8. Over here, I have 4. I need 13. I can't use 6 and 7 because 6 is used here, but 4 and 9 would work. Isn't that nice how mathematics works? And over here, you can just fill them in by default, or you can check it. I like to check it. 17 minus 5 is 12, so I need 5 and 7. So this checks as a solution, and this checks as a solution. Now, it turns out that this problem has a lot of solutions, and I'm not even going to give all of them. 1, 2, and 6, that's 9. I tried it. It doesn't work. At least I don't think it works. You could try some other possibilities. Let's try 1, 5, and 9. 1, 5, and 9, it kind of has nice symmetry here. That's 15. The sum now, 45 plus 15 divided by 3 is 60 divided by 3, which is the sum on each line. So let's try that. One, 5, and 9. You might pause the video and see if you can get 1, 5, and 9 to work. It does work. 1 and 5 down here is 6, so I need 14. I can get 14 with 6 and 8. The 9 is already used, so this only has one solution. I think I found that this has 18 solutions, and you can kind of leverage some symmetry. Since 1, 2, and 3 worked at the bottom of the list, it's probably going to be the case that 7, 8, and 9 work. Of course, the sum is going to be a lot bigger because 7, 8, and 9 are going to be in the corners and get used twice. It would probably be unrealistic on a Math Olympiad test or a college number theory course to expect the student to produce all 18 solutions unless you had some additional strategies. So I have some additional problems for you. Let me share my screen and show those. This first one uses the numbers 1 through 19 in the circles so that the sum of 3 numbers in each line is the same. The second one uses the numbers 1 through 6 so that the sum of 3 circles on the line is the same sum. And this one uses the numbers 1 through 7 so that each line of 3 circles has the same sum. So we have the vertical lines, the horizontal, and the diagonals have to be the same sum. So this is going to be using another variation of the strategy. This has been a video on a general strategy for solving fill-in numbers problems. And you'll find this on my YouTube channel. And here's my YouTube handle. I hope you found this video helpful. Have a great day.